my name is Rupal. I used to work at Atlassian. I'm going to present security made easy for developers topic today. So I'll introduce authentication and authorization concepts, how the authorization flow look like, and most commonly use security for microservices in today's world is like JWT token. So it's a token based security. So majority of my talk will focus more on how to use the token based authentication and how we can even use it for Oauth and OpenID Connect. So I quickly talk about what is authentication. It's a mechanism to make sure that logged in users are genuine. In other words, it's process of verifying identity of a user or a process. So there are two common ways to authenticate. The first one is uh, session-based authentication. So I'm not going to go into too much detail, but at high level, when in session-based authentication, when user logs in, server creates and stores the session information about the logged in user in the database and sends information back to the user, and the browser stores that information in a form of a cookie. And then in the subsequent requests, browser kind of make use of the cookie, and on the other end, the server kind of verifies it. The second authentication is token based. And here we will talk about the JSON Web Token. In short, it's known as JWT. It's a lightweight, stateless authentication mechanism. JWT can be used for authentication and authorization both. And what is authorization? So authorization is a process in security which gives a user permission to access specific resource or a function. For example, if you want to access your contacts, let's say you are trying to log in using the Google-based login into another website. So where you allow your contact information to be shared by the third party app that you are trying to use. So that is called, that is the main purpose of authorization. And it's also interchangeably used with access control or client privilege. In simple words, is what a user can see or do. Going back to JWT, once the user is logged in, subsequent request will include the token, and it will also mention which downstream services the user is trying to access. And under the hood, there is a very small overhead, and it's a very easy and secure way of transmitting information among the client and the server, or on the backend side if multiple microservices are used. So I'll talk a little bit briefly about an example how we can secure access to a service using the token. So in this diagram, you can see at step 1, the user kind of gets the token, logs in, and it receives the token. In step 2, the app sends the token along with the request to the service. In step 3, the service kind of verifies the token, and then in step 4, the user receives the response if the token is valid. So the token in the authorization flow, the token that I'm talking about, it has 3 parts. The first part is the payload header. The second part is the payload, and the third part is the signature. So when client sends the token in authorization header, service validates the token and verifies the signature and verifies the claims. We'll look into more detail in upcoming slides. So these are some examples of how the different parts of the token looks like. Like you can see they are all URL encoded. So on the left, you can see the header encoded, and on the right, you can see it talks about what type of token it is and what kind of algorithm is used for securing the token. The second part is the payload, where on the right, you can see it's base64 encoded string. It says who was the issuer and who is the end audience is typically who is the end user of this token, and EXP stands for expiration, and that's the expiration time of this token. And signature is very similar to signature, like pretty much using the cryptographic signature. So digital signature. So the header kind of contains algorithm name and the type, and sometimes it also contains the key identifier. And then payload kind of contains information like what kind of downstream resources the user is trying to access, who is the issuer, expiration time, and the token identifier. Sometimes it includes additional information like what was the issue time, and some additional ones like subject and not before. And the signature part is typically created using the shared secret key between the client and server, and it's whatever algorithm is mentioned in the header, so that is used to kind of generate the signature. So in this example, we are using the shared secret where client and server both have the same secret for generating the signature. And in this example, we are using private key. The calling service uses their own private key to sign, and then when the end user receives it, it uses the public key to kind of encrypt and verify the signature. So let's drill down into this example when we try to use public key in real world scenario where we have when I have shown this example where we use a secure token service, which kind of takes care of generating the token and doing all the validation. So in this example, when service one starts, it calls the secure service to generate the public and private key. And using the private key, it creates the token, and then it calls the service two's endpoints. And then service two again calls the secure token service in step 4 to look up the public key. And then in step 5, service 2 tries to parse the token. And then on step 6, if it's successful, it verifies the claim and call the downstream service or the resource. So we'll look into like OAuth 2. So in this case, like I was talking about earlier, when we are like logging using sign in with Google as an example. So what happens is we get a callback URL and the scope, and then user enters the login password, and then it will basically also have list of scopes. So scope is nothing but what exactly you're trying to access. For example, if you want to allow the third-party app to access your contact or your email or whatever that list it will give. and then it returns the authorization code. And then the auth server will also exchange authorization code for the access token, and the client's backend service. So authorization server will use the callback URL in the earlier call to contact the client's backend service with the authorization code. And then the client's backend service will use the access token to access the resources. So this is how the OAuth2 works. So if there are any questions, like maybe you can take it towards the end. So OAuth2 is also commonly used with OpenID Connect. So where we already, like I already talked about this part where the OAuth2 kind of flow works. So pretty much exchange the authorization code for the access token, and then clients backend uses that information to call the API gateway. So the API gateway in this case intercepts the request and verifies the token ID by calling the internal token service. So in this example, the internal token service is security token service. And then it generates a new JWT token. And then that new JWT token is used to call the downstream service. So in this example, we are trying to like do some online shopping, and first we establish the authentication and authorization of logged in user using OAuth2. And then when the end user is ready to add something to their shopping cart, at that time, the API gateway will intercept the request and it will generate a new token, which will be used by the internal service. Like for example, in this case, shopping cart service will receive that token request and validate the token and kind of add the item to the cart, and it will further process by downstream. So some of the best practices, number one thing that we typically don't recommend doing is storing this secret key or even the public key, private key information as a plain text in the code, or store it in environment variables or directly in the Docker configuration file. So there are some common ways of storing securely using Vault or AWS Key Management Service. And the oauth.org has good information on security-based practices. So there are some other ways outside the JSON Web Token is the X509 certificates. And you can also refer to this RFC for more information. And there are different ways you can embed the public key inside as well. And I have like some code examples where you can like, it all looks a lot, but it is like not very difficult to implement in the code. So we can pretty much like do it. This is an example in Java, and then you can kind of parse the token in Java. So here, like you are building the token, like you are adding all the time, what time you're issuing the token, your subject, who is the issuer, the algorithm, and then like here you're parsing the token and then verifying the signature. And same thing we can achieve in Python, where you can generate the key using encode function and passing all the parameters inside. And then there's the same thing. And then you can verify the token by calling the decode function and then passing the shared secret key. And then if you are using like public key, we'll have to first like generate the private key and then use it to encode using the private key. And for verifying, we will be using the public key to verify. Yeah, I think I'm pretty much done. We have like 3 minutes left. And I can take any questions if anybody has any questions. Oh yeah, so somebody's asking what is the public key and private key. So private key remains secret like to the client or the server, and public key will be shared, openly available. So typically when you kind of browse any URL where you see HTTPS, then at that time your client browser will be downloading the server's public key. So that is usually available through different authorized parties, and they kind of maintain the public key of various providers. And are storing tokens in the browser generally safe? So typically we don't recommend like storing tokens in the browser. So, but they are like pretty much like they are like base 64 encoded tokens. So anybody can use it. Only part you should not be storing in the browser is the secret key in a plain text format. Yeah. So I mean, I think not sharing while talking, but here is my Python notebook. If anybody interested can ping me separately.